Hello, welcome to LeetCode C# channel. Today we're going to look at the LeetCode problem number 9, Palindrome Number. Determine whether an integer is a palindrome. An integer is a palindrome when it reads the same backward as forward. Okay, that's straightforward. So example number 1, the input is 1 to 1. Of course, it's palindrome. If you read backwards, it's the same as the forward. Second example is minus 1 to 1. It is not. The output should be false because it's minus. It's a minus number. Third example, input 1, 0, output is false. So there's a follow-up question. Could you solve it without converting the integer to a string? Okay, so we're going to look at this problem, look at the solution in 3 different ways. Let's suppose we don't have this condition. If it does allow us to convert to a string, that's the most straightforward solution. Let's look at it quickly. So let's start with eliminate the input if it's a minus number. Okay, so if we say if x less than 0, we're going to just return false. Okay, so since we say the string is allowed in the most straightforward solution, so we convert this to string. So it's going to be, once we convert to string, it's going to be very simple. We're going to use 2 pointers. One is the forward pointer, pointing to point to the beginning of the string. Another is the backward pointer, pointing to the end of the string. So we're going to say, let's say leading pointer or tailing pointer, trailing pointer, I mean, L. So we start as 0. Trailing pointer, we start, it's going to be string dot length because 0 based minus 1. So we're going to compare each digit of the leading pointer points to with the digit of the trailing point points to, and if that's the actually we're going to compare, say if it's not equal, that's the leading point, that's a trailing pointer points to, now we're return false. Okay, so we can increment or increment the leading pointer and decrement the trailing pointer. We can do it here to make it more compact. So otherwise it is palindrome number. Okay, let's run the code. Okay, it passed the case. Let's try another one. Nine 1019. Okay, it does pass. Let's submit. Accepted. Okay. That's the first most straightforward solution. Now the second way of solving this problem, we're going to use a previous video LeetCode problem number 7, I believe. It's we wrote a function of reverse integer. Let's look at that function. So that's the LeetCode problem number 7, reverse an integer. So basically that's the function. We're not going to go through this function step by step today. We're going to put a link in the description, so if you want to watch that video in its entirety, you can go ahead and watch that video. We're going to put the link there. So we're going to just copy this function. Gonna go back. Okay, that's the original problem. I'm gonna paste that reverse function here. So on new solution, let's get rid of this string solution. We're going just to say okay, if x less than 0, we're going to make that test. If it is, we return false. Otherwise, we don't call reverse function. So we're going to reverse the number, and if the palindrome is going to read the same backward as forward, it's going to equal to the original. I mean that's x. Okay, let's run the code. Okay, accept it. Let's submit. Okay, it's about same performance, 72 milliseconds. Okay, that's going to be the second solution. The third solution, we're going to actually write a function. Let me remove this reverse function, and we're going to strictly obey this by solving the problem without converting the integer into a string. So let's say how we're going to do that. Of course, we're going to still do the same thing at the beginning to check for the negative integer. If it's negative, we're going to return false. And the way we're going to do it is without converting to a string, we're going to compare the leading digit with the trailing digit one at a time. So for that purpose, we're going to need a number, an integer n defined as the length of the integer x. So the way we're going to find out the length is we're going to take logarithm of the number of base 10. Okay, so we're going to, of course, I think that's a double if I'm not mistaken, and actually we need to add 1. So that's the length of the integer x. Now we're going to define integer I, initialize with the number 1. So we're going to start the loop by looking at the leading digit and the trailing digit one at a time. So we're going to say while I is less than or equal to, actually we're not going to move the pointer all the way to the end. We just need to compare until the half point of the integer. So that's how we're going to do it. So we compare if I less or equal to n over 2, that's the half length of that integer. So again, the leading digit with the leading with the integer variable. The way we're going to find out the leading digit is we're going to take the original digit divided by we're going to take base 10 of the power of we're going to get that n minus I, where n is the length of the integer, and n with the initial value of 1. So that's going to be the leading digit of the current state, the first cycle of the loop. We're going to do a trailing digit. It's going to be x of module 10, right? So the comparison is going to be if leading digit is not equal to trailing digit, we're going to return false. If we do false through the loop, we're going to return true. Now we're going to reduce the number, the integer, by dividing the number by 10. So we basically move the trailing pointer to the left with 1 digit. And the length, of course, is still, we use the same formula to calculate the length of the new integer after the original digit divided by 10. Okay, and we're going to move that forward pointer. Okay, so here in the first loop, for example, if the number is 1 to 1, the leading digit is 1 to 1 divided by tens of the power of 2. It's going to be 100. So that's going to be, the leading digit is going to be 1. That's correct. Okay. Now the second round, because the x we divided by 10 is going to be 1, 2. Okay, it's going to be 1, 2. Then how are we going to get the leading digit? We don't want 1 anymore. 1 is done. We're going to say we're going to look at 2, the number 2. Okay, so how are you going to get the 2? If we do 1, 2 divided by power of 10, n right now is 2 minus okay, n is 2 minus 2, right? So the number is 1, 2, right? If you divide it by power of 10 to the power of 0, it's going to be 1. So this number is 1, 2. So it's not the leading digit. In order to get the leading digit, what we can do, maybe we want 2, okay, but this is a 1, 2. What we can do, we take the number of tens module, and it's going to be 2, right? The trailing digit still we get from that. That's our formula comparison, and with that, a little modification to figure out the leading digit. Let's see if the function is going to work. Let's run the code. Okay. Oh, that's a double actually. So we need to convert that, I believe. Okay, let's try again. Okay, and it works. Let's try to submit. We have wrong answer, output is true, expected false. Okay, you know what? When we looping through the integer, we're truncating the last digit, the trailing digit 1 digit at a time. So by dividing by 10, so then the length of n of the integer is also decreasing. But in reality, when we loop through the integer, we really need to loop through the half of the length of the original number. So here, because n is changing within the loop, that n is not the original length of the integer anymore. So we need to actually modify that a little bit. We need to say, give it, this is the original n, And we need to still define the integer n, initialize that n equals to initial original n. Here we're going to do n0 divided by 2. That's the original length of the integer, original integer. Okay, let's try that. Let's try change the input to this. Run code. Okay, it worked. Let's submit the solution. Okay, this answer is accepted. Okay, that's all for today. Please subscribe and like. Happy coding. See you next time. Bye bye.